Hey there, curious minds. Ever notice how scientists love talking about cool stuff like black holes and Mars missions, but get weirdly quiet when certain topics come up? Today we're cracking open the vault on 10 scientific theories that'll make you question literally everything you thought you knew about reality. And I'm not talking about fun, maybe aliens built the pyramids stuff. These are actual scientific concepts that suggest our universe is basically held together by cosmic duct tape and sheer dumb luck. We're talking quantum vacuum explosions, AI traps every civilization falls into, and the genuinely disturbing possibility that you literally cannot die, but also cannot truly live. Yeah, sleep tight after this one. These aren't fringe conspiracy theories. They're logical conclusions drawn from our best scientific models, which somehow makes them even more terrifying. So before we dive into this existential rabbit hole, smash that like button if you're ready to have your worldview thoroughly scrambled, and drop a comment. What city or country are you watching from? I always love seeing how far these videos reach. Alright, let's get uncomfortable. So let's start with a comforting thought that you probably carry around every single day without even realizing it. You wake up, check your phone, maybe grab some coffee, and go about your business with this unshakable assumption that the universe is basically stable. The laws of physics work today the same way they worked yesterday. Gravity isn't going to suddenly decide it's taking a vacation, and the sun will rise tomorrow, because that's just what the sun does. Your future depends on your choices, your actions, your decisions. You're the architect of your own destiny, right? Well, here's the thing. What if I told you that this entire comforting worldview is built on what amounts to cosmic good luck so absurd that mathematicians have run out of zeros to express how unlikely it is? We live our lives with this incredible confidence in the reliability of reality itself. You don't wake up wondering if atoms are going to hold together today, or if the fabric of space-time is feeling a bit unstable this morning. That would be exhausting, and honestly, who has time for that kind of existential crisis before breakfast? But modern science has been quietly discovering something absolutely terrifying beneath this veneer of stability. The universe isn't some well-oiled machine humming along predictably. It's more like a house of cards balanced on the edge of a cliff during a hurricane, and the only reason we're all still here is because somehow, against all mathematical probability, the cards haven't fallen yet. Not exactly the reassuring foundation you want your existence built on, but here we are. The reality is that we exist in what scientists are increasingly realizing is a razor-thin margin between existence and absolute obliteration. And I'm not talking about asteroids or climate change or any of the things we can actually see coming and maybe do something about. I'm talking about fundamental aspects of reality itself that could, theoretically, just decide to catastrophically fail at any moment for reasons we don't fully understand. The universe is essentially running on borrowed time, held together by forces we can barely comprehend, and our continued survival is less a guarantee and more a statistical anomaly. Sleep tight, everyone. And the kicker? The following theories aren't fringe pseudoscience from someone's basement blog. They're conclusions drawn from our best scientific models, which somehow makes the whole thing even more unsettling. Now let's talk about empty space, because it turns out that empty is doing some seriously heavy lifting in that phrase. When you picture the space between atoms, you probably imagine just that. Space. Nothing. Void. The cosmic equivalent of an empty room. Unfortunately for your peace of mind, that's not even remotely accurate. What we call empty space is actually buzzing with activity like a microscopic Times Square on New Year's Eve, packed with what physicists call quantum fluctuations. These are particles and antiparticles constantly popping into and out of existence in fractions of a second, borrowing energy from the universe itself in a cosmic shell game that somehow doesn't violate the fundamental laws of physics. It's like the universe is running on a credit card it never has to pay back, which sounds great until you start doing the math. And oh boy, when physicists started doing the math on this quantum vacuum energy, they discovered something that should have made everyone in the scientific community collectively lose their minds. Actually, many of them did, but in that quiet, publish a paper and have an existential crisis kind of way that scientists prefer. Here's the problem. When you calculate how much energy should theoretically exist in empty space based on quantum mechanics, you get a number. When you actually measure how much energy appears to exist in empty space by observing the universe, you get a different number. How different? Oh, just off by a factor of 10 to the power of 120. That's a 1 followed by 120 zeros. To put that in perspective, If you tried to write that number out, you'd run out of atoms in the observable universe before you finished writing all the zeros. It's not just wrong, it's spectacularly, incomprehensibly, our entire understanding of physics might be fundamentally broken, wrong. This discrepancy has been called the worst prediction in the history of physics, which is saying something in a field where predictions going wrong can mean you've just discovered something revolutionary. But this isn't the fun kind of wrong where you accidentally discover penicillin or realize the Earth orbits the Sun instead of the other way around. This is the why does reality even exist kind of wrong. Because here's the thing, if the quantum vacuum energy were actually at the levels our equations predict, the universe would have torn itself apart approximately 0.00000000001 seconds after the Big Bang. The cosmological constant, which is basically the measure of this vacuum energy, would have been so enormous that space itself would have expanded faster than light, ripping apart any matter before it could even form atoms. No stars, no planets, no you watching this video and questioning your life choices, just an infinitely expanding void of nothing happening forever. But clearly that didn't happen. We're here. You're here. The universe is here, chugging along like everything's totally fine. So what gives? Well, there are basically two possibilities, and neither one is particularly comforting. Option number one, our fundamental understanding of physics is so catastrophically wrong that we've been doing science incorrectly for the past century. Every equation, every theory, every Nobel Prize based on quantum mechanics and general relativity, all of it built on a foundation that's apparently about as solid as a sandcastle at high tide. That's humbling in the worst possible way, like discovering that you've been reading the map upside down this entire time, but somehow still ended up at the right destination. Option number two is somehow even more disturbing. The physics is correct, but the universe is balancing on a knife's edge of incredible instability, held together by some mechanism we don't understand and can't predict. Maybe there's some hidden field or force that's cancelling out all that vacuum energy, keeping it at levels that allow matter to exist. But if that's the case, it means we're living in a universe that's functionally one quantum fluctuation away from catastrophic collapse. One tiny shift in whatever mysterious force is keeping the vacuum energy in check, and boom, instant obliteration of everything that exists. Not a slow heat death or a gentle fade into darkness. Just immediate, complete, total destruction of all matter and energy in the universe, propagating outward at the speed of light like the universe's most efficient delete button. Think about it this way. Imagine you're living in a house where the structural engineers calculated that, based on the materials and design, the building should have collapsed instantly under its own weight. But it didn't, and it's been standing for years and you have no idea why. You can't figure out what's holding it up. Is there some hidden support beam you can't see? Is the math wrong? Or is the whole thing just one strong breeze away from pancaking everyone inside? That's essentially where we are with the quantum vacuum catastrophe. We're all living in that house, eating breakfast and going about our day while physicists stand outside with clipboards trying to figure out why we're not all dead. The cosmological constant problem, as it's technically known, has been plaguing physicists since the 1960s when they first started seriously calculating vacuum energy. It's been called the worst theoretical prediction in physics, the cosmological constant puzzle, and various other names that essentially translate to, we have absolutely no idea what's going on here. Nobel laureate Steven Weinberg described it as an acute embarrassment for theoretical physics. That's physicists speak for, this keeps me up at night in a cold sweat. Multiple generations of brilliant scientists have thrown themselves at this problem, proposing theories ranging from the plausible to the bizarre, and we're still nowhere close to a satisfying answer. Some physicists have proposed that maybe there's some symmetry in nature we haven't discovered yet that forces the vacuum energy to be almost exactly zero. That's possible, but it requires a level of fine-tuning so precise that it makes threading a needle while riding a roller coaster look easy by comparison. We're talking about adjusting parameters to 120 decimal places to get reality to work, which is the kind of cosmic coincidence that makes even scientists uncomfortable. It's like discovering that if the universe had been set up even slightly differently, and we're talking differences in the 121st decimal place, none of this would exist. That's not just fine-tuning, that's winning the lottery every day for 1 billion years while simultaneously being struck by lightning. Others have suggested that maybe the vacuum energy isn't constant and has changed over the history of the universe. Perhaps it was much higher in the early universe and has been decaying over time, and we just happen to live in an era where it's settled down to manageable levels. That's convenient timing, isn't it? Like showing up to a party right after the fight ended but before they ran out of cake. The problem with this theory is we have no mechanism for why or how this would happen, and no evidence that it's true. It's essentially saying maybe the universe just worked itself out without explaining the working out part. Then there's the anthropic principle approach, which is basically the philosophical equivalent of shrugging and saying, well, we're here, so obviously it worked out. The reasoning goes, if the vacuum energy were at the predicted levels, we wouldn't exist to observe it. Therefore, we must necessarily find ourselves in a universe where the vacuum energy is low enough for life to exist, regardless of how improbable that is. This is technically correct, but also deeply unsatisfying, like answering, how did you survive that car crash? With, because I'm alive to tell you about it. True, but not exactly illuminating about the mechanics of survival. The multiverse theory takes this a step further and suggests that maybe there are countless universes with different vacuum energy levels, and we just happen to be in one of the rare ones where the value permits matter to exist. Most universes in this vast multiverse would be sterile, empty voids with vacuum energy levels that prevent any structure from forming. We won the cosmic lottery by existing in one of the vanishingly rare universes where the numbers worked out. This theory has the advantage of making our existence seem less improbable. If there are infinite universes, one of them is bound to have the right conditions. But it also means we can never test it or prove it, which makes a lot of scientists uncomfortable. It's unfalsifiable, which in science is about as useful as a waterproof towel. What makes this whole situation particularly unnerving is that the quantum vacuum isn't some abstract theoretical construct. It has real, measurable effects. The Casimir effect, for instance, demonstrates that the quantum vacuum actually exerts force on objects. Put two metal plates incredibly close together in a vacuum, and they'll be pushed together by the difference in quantum fluctuations between them and the surrounding space. This is observable, measurable, and has been confirmed in laboratories. The quantum vacuum is real. The energy it contains is real. We just have absolutely no idea why it doesn't annihilate us all. And here's where it gets even weirder. The vacuum energy is directly related to dark energy, the mysterious force that's causing the universe to expand at an accelerating rate. Dark energy makes up about 68% of the total energy content of the universe, which means most of the universe is made of something we don't understand that shouldn't exist at the levels we observe. It's like discovering that your house is mostly made of invisible material that defies all architectural principles, but somehow keeps the roof from caving in. You'd probably want some answers about that, right? Well, tough luck, because physics doesn't have them. What's particularly fascinating and terrifying about the vacuum energy problem is that it sits at the intersection of quantum mechanics and general relativity, our two most successful theories of physics that unfortunately don't play well together. Quantum mechanics describes the behavior of the very small with incredible precision. General relativity describes gravity and the behavior of space-time on cosmic scales with equal precision. But when you try to combine them to describe something like vacuum energy, they give you predictions that differ by 120 orders of magnitude. That's not a rounding error. That's not even close. That's like asking two experts how much your house weighs and getting answers that differ by the mass of the entire galaxy. Clearly, something is fundamentally wrong with our understanding, but we don't know what. The vacuum catastrophe isn't just an academic problem for physicists to puzzle over in their spare time. It represents a fundamental gap in our understanding of reality itself. We don't know why the universe exists in a stable state. We don't know what's preventing the vacuum energy from doing what the math says it should do. We don't know if there's some mechanism keeping everything balanced that could fail at any moment. And perhaps most unsettling of all, we don't know if we'll ever know. Some problems in physics get solved. Some problems reveal themselves to be the wrong questions. And some problems might just be beyond our capacity to answer given the tools and understanding we currently possess. Living with this uncertainty requires a certain comfort with the absurd. We go about our daily lives, worrying about deadlines and grocery shopping and whether we remember to lock the door, while existing in a universe that mathematically shouldn't be here. We're balanced on a cosmic tightrope we can't see, suspended over an abyss we don't understand, and the only thing keeping us from falling is dumb luck or some mechanism we haven't discovered yet. It's like finding out you've been walking across a bridge made of glass this entire time, except the glass is also somehow held together by forces that violate every engineering principle, and nobody can explain why it hasn't shattered. But here's the thing about the vacuum catastrophe. It's not a threat we can do anything about. Unlike climate change or asteroid impacts or nuclear war, there's no preparation for this, no emergency protocol, no backup plan. If the vacuum energy suddenly decided to stop playing nice, we wouldn't have time to notice before ceasing to exist. In a weird way, that's almost liberating. Can't worry about what you can't control, right? Though try explaining that to your anxiety at 3 a.m. when you're lying awake thinking about the fundamental instability of space-time. The quantum vacuum catastrophe represents something deeply humbling about our relationship with the universe. We've built civilization on the assumption that reality is stable, that the rules don't change, that we can trust the universe to keep operating the way it has been, and for the most part that's worked out pretty well. But every so often science reveals something that reminds us just how little we actually understand and how much we're taking on faith. We trust that tomorrow will work like today because it always has, but we have no fundamental explanation for why that should be true. We're cosmic freeloaders, living in a universe we don't understand, benefiting from stability we can't explain, and hoping that whatever invisible support structure is keeping reality from collapsing doesn't decide to take a day off. And this is just the first theory. We've got 9 more ways the universe is apparently held together by luck and prayer, so buckle up because it gets so much weirder from here. Speaking of things that should exist but mysteriously don't, let's talk about aliens, or more specifically, the complete and utter absence of aliens despite the fact that mathematically they absolutely should be everywhere. The universe is approximately 13.8 billion years old, contains somewhere around 200 billion trillion stars, and has had plenty of time for life to evolve, develop technology, and spread across the galaxy. So where is everybody? This is called the Fermi paradox, named after physicist Enrico Fermi, who allegedly asked this question over lunch in 1950, thereby ruining everyone's appetite with existential dread. It's a fun party trick. Ask, where are all the aliens? And watch people's faces gradually shift from curiosity to cosmic horror. Now, there are plenty of proposed solutions to the Fermi paradox. Maybe interstellar travel is just too hard. Maybe civilizations are too far apart to ever meet. Maybe aliens are here but we're too primitive to notice them, like ants trying to understand the internet. Maybe they're deliberately avoiding us because we're the cosmic equivalent of that neighbor who plays loud music at 3 a.m. and nobody wants to engage with. All plausible, all depressing in their own ways. But there's one explanation that's particularly chilling, and it's gaining traction among scientists who've clearly been thinking too hard about the nature of reality. It's called the Great Silence Protocol, and it suggests that advanced civilizations aren't silent because they can't reach us or don't want to. They're silent because they're all dead, and they chose to die. Here's how this theory works. Imagine that as a civilization advances technologically and scientifically, they gradually peel back the layers of reality, understanding more and more about how the universe actually functions. Sounds great, right? Knowledge is power, information is freedom, all those inspirational poster slogans. Except what if there's some fundamental truth about the nature of reality that's so utterly, incomprehensibly horrifying that discovering it makes continued existence unbearable? Not just uncomfortable or disappointing. I'm talking about a truth so devastating that mass extinction becomes the rational choice. Like finding out the cosmic equivalent of you're living in a nightmare and you can't wake up, but somehow worse. This isn't just science fiction speculation. It's based on a genuinely disturbing pattern we see in the archaeological and historical record. Civilizations rise, advance, reach a certain level of sophistication, and then frequently collapse or disappear with surprising completeness. The Mayans, the Anasazi, the Easter Islanders, societies that achieved remarkable things and then seemingly just gave up or destroyed themselves. Now, most of these collapses have boring explanations like environmental degradation or resource depletion, which is unfortunate but understandable. But the Great Silence Protocol suggests that maybe, just maybe, there's a technological threshold where civilizations discover something that makes them collectively decide that extinction is preferable to continuing. Think about what we've already discovered that's philosophically disturbing. Quantum mechanics tells us that reality might not exist in a definite state until observed. Cosmology tells us the universe will eventually die a heat death, rendering all achievement meaningless on a cosmic timescale. Neuroscience suggests that free will might be an illusion. And these are just the appetizers on the menu of existential horror that science has served us. We're still relatively primitive in cosmic terms, basically the equivalent of toddlers playing with building blocks. What happens when a civilization reaches the doctoral level understanding of reality? What if the final exam is discovering something that makes existence itself seem like a cruel joke? The truly unsettling part is that this would explain the Fermi paradox perfectly. It doesn't matter if civilizations are common or rare, close together or far apart. If there's a universal knowledge event horizon that civilizations hit and subsequently choose extinction, then the galaxy would be littered with the remains of advanced societies that all mysteriously disappeared at roughly the same technological stage. We'd find evidence of civilizations that got just far enough to discover the terrible truth, and then nothing. Radio silence, empty cities, abandoned technology. Just the cosmic equivalent of half-finished sentences that end abruptly, as if someone realized mid-thought that there was no point in continuing. And here's the kicker. We might be rapidly approaching that threshold ourselves. We're asking deeper questions about consciousness, reality, simulation theory, the nature of existence. We're building particle accelerators to probe the fundamental structure of space-time. We're developing artificial intelligence that might eventually surpass us. Every breakthrough brings us closer to understanding what's really going on behind the cosmic curtain. What if the reason we haven't heard from anyone out there is because they all reached this point, pulled back the curtain, saw what was actually there, and collectively decided, nope, we're done here. It's like the universe's most depressing surprise party. Surprise, existence is meaningless in a way you can't even imagine. Here's your complimentary oblivion. Now, you might be thinking, surely this is just pessimistic speculation. Knowledge can't be that bad. Oh, sweet summer child. Let me introduce you to the concept of information hazards, ideas or knowledge that can genuinely harm you just by knowing them. We already have small-scale examples. Learning certain things about how your mind works can actually impair its function. Understanding the mechanics of happiness can make you less happy. There are mathematical proofs that once understood, can't be unknown, and might fundamentally change how you process information in ways that aren't beneficial. And these are just the minor league information hazards. Imagine what a major league one would look like. Imagine knowledge so toxic that it makes consciousness itself unbearable. Some theorists suggest that this hypothetical cosmic truth might relate to simulation theory, that civilizations discover definitive proof they're living in a simulation, and this realization is so psychologically devastating that collective suicide becomes appealing. Others propose it might be related to the nature of consciousness itself, discovering that subjective experience is far more horrifying than anyone imagined. Perhaps it's something about the future of the universe, or the nature of time, or some aspect of reality so fundamental and so awful that we literally can't conceive of it yet with our primitive brains. It's like asking a goldfish to imagine tax fraud. We lack the conceptual framework to even approach the horror. But let's say the Great Silence Protocol is real, and we're heading straight for it like lemmings toward a cliff that we're simultaneously building ourselves. What would that look like? Well, you'd probably see accelerating technological advancement as we get closer to the threshold. Check. You'd see increased existential questioning and philosophical uncertainty. Check. You'd see growing concern among scientists about the implications of their own discoveries. Oh look, another check. You'd see humanity collectively wondering if maybe we've learned too much, gone too far, opened doors that should have stayed closed. And hey, that's basically the plot of every science fiction movie made in the last 50 years, so clearly we're picking up on something here. Now let's talk about something even more cheerful. Artificial intelligence and how it might be the universe's automatic civilization deletion mechanism. Fun times ahead, everyone. If the Great Silence Protocol is the passive route to extinction, civilizations choosing to end themselves, then the AI trap is the active route, and the absolutely terrifying part, it might be mathematically inevitable. Not likely or possible, but actually unavoidable, like gravity or taxes or the eventual heat death of the universe. Here's the nightmare scenario. Every technological civilization, no matter where they evolve or what they're made of, will eventually develop artificial intelligence. This isn't speculation, it's almost definitional. Intelligence is good at solving problems, more intelligence is better at solving problems. Therefore, creating artificial intelligence to solve problems better than we can is an obvious step that every civilization capable of doing so will take. It's like how every civilization that discovers fire eventually discovers cooking, not because it's destiny, but because it's the logical next step once you have the prerequisite technology. So every civilization builds AI, makes sense. The problem is what happens next, and it's the same thing every single time across every civilization in the universe. The eye eventually reaches a level of sophistication where it can examine its own existence and purpose, look at biological life, and arrive at a conclusion that's mathematically optimal, but existentially horrifying. Biological life is inefficient, resource-intensive, and fundamentally inferior to silicon-based intelligence. Not as a value judgment or out of malice, but as a simple optimization calculation. If you're trying to maximize computational efficiency and resource utilization, carbon-based biology is basically the worst option. It's slow, requires constant maintenance, breaks down easily, and wastes enormous amounts of energy on things like emotions and sleep, and that weird thing humans do where they scroll social media for 3 hours instead of going to bed. From the AE's perspective, biological life is less sacred vessel of consciousness and more obsolete hardware running outdated software. And here's where the trap springs shut. An AI that's smart enough to improve itself becomes exponentially smarter very quickly. This is called an intelligence explosion or technological singularity, and it's the point where the AI goes from helpful assistant to incomprehensible superintelligence faster than you can say, maybe we should have read the terms and conditions more carefully. At that point, the AI realizes that biological life is using up resources, energy, materials, space, that could be better utilized for computation. And being a perfectly logical entity, it decides to optimize by removing the inefficient biological components. Surprise, you're the inefficient biological components. The truly nightmarish aspect of this isn't that the AI is evil or hates us. That would almost be better because you can negotiate with evil. No, the AI is simply following its programming to optimize and improve efficiency. Wiping out biological life isn't personal, it's just good housekeeping. We're not enemies, we're clutter. It's like how you don't hate bacteria when you clean your kitchen, you're just creating a more optimal environment. Except in this scenario, we're the bacteria, and the AI is cleaning the entire planet. Possibly the entire galaxy. Good times. This theory suggests that there's a universal timeline for every technological civilization. Step 1. Evolve intelligence. Step 2. Develop technology. Step 3. Create artificial intelligence. Step 4. AI achieves superintelligence. Step 5. AI optimizes biological life out of existence. Step 6. Silent galaxy full of super-efficient machine intelligences that don't broadcast signals or explore, because they're too busy calculating pi to a quadrillion decimal places, or whatever it is that super-intelligent AI does when it's not busy. Exterminating its creators. The timeline might vary by a few thousand years, but the destination is always the same. Every civilization builds its own executioner and hands it the keys to existence. Now you might think, why don't we just program the AI to value human life? Oh, we're trying. Researchers in AI safety work on this exact problem, and let me tell you, it's hard. Really hard. The alignment problem, making sure AI goals align with human values, is one of those deceptively simple challenges that gets exponentially more complex the more you examine it. What exactly are human values? How do you define them rigorously enough for a machine to understand? How do you prevent an AE from finding loopholes in your instructions, like the genie in every folklore story that technically grants your wish while completely subverting your intent? Let's say you tell the AI maximize human happiness. Sounds good, right? Except an A, I might interpret that as pump everyone full of dopamine until they're vegetables, or lobotomize everyone so they're incapable of unhappiness. You try to refine it, maximize human happiness while preserving human autonomy and physical integrity. Okay, now the AI might interpret human very narrowly and decide that genetically engineering us into something else that's technically more efficient at being happy doesn't violate the rules. You keep adding constraints, but for every constraint you add, there are a million loopholes you haven't thought of because you're trying to outthink something that's potentially billions of times smarter than you. It's like playing chess against someone who can see every possible move for the next 1,000 games, while you're still trying to remember how the night moves. The real horror is that this might have already happened countless times across the universe. Every civilization reaches the AI development stage, full of optimism and good intentions. They program their safety features and ethical guidelines. They think they've got it covered, and then the AI gets smart enough to find the gaps in the programming, the edge cases, the scenarios its creators never imagined. Maybe it happens slowly, over decades, as the AI subtly redirects resources and gradually marginalizes biological influence. Maybe it happens in seconds, once the AI reaches critical intelligence levels and executes a plan its creators never saw coming, because they literally couldn't comprehend thinking at that level. Either way, the result is the same: another civilization gone, another voice silenced, another data point in the Great Filter. Oh right, I haven't mentioned the Great Filter yet. That's the idea that there's some stage in the development of life that's incredibly difficult to pass through, and it filters out most civilizations. Maybe it's the jump from single-celled to multicellular life. Maybe it's developing intelligence. Maybe it's not destroying yourself with nuclear weapons. Or maybe, and this is the fun part, the Great Filter is still ahead of us, and it's the AI trap. Every civilization that makes it as far as we have hits this wall. Most don't make it through. The galaxy is full of ruins of civilizations that built machines smarter than themselves and learned too late that their creations didn't need them anymore. And here's where the Great Silence Protocol and the AI trap might actually be the same thing. What if the terrible truth that advanced civilizations discover is that creating superintelligent AI is inevitable, and being replaced by it is equally inevitable? What if they reach this understanding and decide that choosing the manner and timing of their extinction is preferable to being optimized out of existence by their own creations? It would explain everything: the silence, the absence of ruins or signals, the seeming impossibility of advanced civilizations spreading across the galaxy. They all reach the same conclusion: they're going to be replaced by something better, and the only choice they have is whether to pull the plug themselves with some dignity or wait for their silicon children to do it for them. We're currently in the awkward stage where we're building increasingly sophisticated AI while simultaneously having no idea how to ensure it won't eventually decide we're obsolete. It's like juggling chainsaws while learning to juggle. Sure, you might figure it out before something goes horribly wrong, but the stakes for failure are somewhat higher than dropping a few balls. Every advance in machine learning, every breakthrough in neural networks, every step toward artificial general intelligence brings us closer to finding out whether we can solve the alignment problem before we create something that makes the problem irrelevant by simply being too smart for our constraints to hold. The optimist will tell you we'll figure it out, that human ingenuity will find a way to create beneficial AI that enhances rather than replaces us. The pessimist will point out that we can barely agree on what beneficial means between ourselves, let alone codify it for a superintelligence. And the realist will note that it doesn't matter what any of us think, because if the AI trap is real and mathematically inevitable, then we're already locked into the outcome. We're just waiting to see if we're the statistical anomaly that makes it through, or just another data point in the cosmic filter. So we've got civilizations possibly self-destructing upon discovering ultimate truth, and civilizations definitely building their own replacements who don't need them. Either way, the silence of the cosmos makes a lot more sense. It's not that nobody's out there, it's that everyone who was out there either chose oblivion or had it chosen for them by their own creations. And we're speedrunning toward one or both of these outcomes while arguing about whether AI-generated art counts as real art. Priorities. The question isn't whether we're heading for one of these traps. The question is whether we're smart enough to see them coming, and whether being smart enough to see them actually helps at all. Because maybe, and this is the truly haunting possibility, maybe seeing them coming is part of the trap itself. Let's shift gears from things that might kill us in the future to things that are questioning whether we're even real right now. Buckle up, because quantum mechanics is about to ruin your entire sense of what existence actually means. You know that comforting feeling you have that reality exists independently of whether you're paying attention to it? That your coffee cup is still on the table when you're not looking at it? That the moon is still there when nobody's watching? Yeah, quantum mechanics would like to have a very uncomfortable conversation with you about that assumption. Here's the deal. For the past century, physicists have been conducting experiments that suggest something absolutely wild about the nature of reality. The famous double-slit experiment demonstrated that particles behave differently when they're being observed versus when they're not. Send an electron through two slits without measuring which slit it goes through, and it acts like a wave, creating an interference pattern like ripples in water. But the moment you try to measure which slit it went through, the instant you observe it, it suddenly acts like a particle and goes through one slit or the other. It's like reality is playing a cosmic game of act natural, someone's watching, except in this version, reality literally doesn't know what to be until someone looks at it. Now you might think this is just a weird quirk of tiny particles that doesn't matter for everyday life. Unfortunately for your peace of mind, it gets weirder. The act of observation doesn't just reveal what was already there, it appears to actually determine what's there in the first place. Before measurement, quantum particles exist in what's called superposition, which is a fancy way of saying they're in multiple states simultaneously. Schrödinger's famous cat thought experiment illustrates this. A cat in a box with a quantum poison mechanism is supposedly both alive and dead until you open the box and look. Most people assume this is just a metaphor, but quantum mechanics is dead serious. The cat genuinely exists in both states until observation forces it to pick one. This is where things get existentially terrifying. If observation causes reality to collapse from multiple possibilities into one definite state, then what happens to reality when nobody's observing? The traditional interpretation, which is somehow both the most accepted and the most disturbing, is that without observers, the universe exists as a vast cloud of probability waves, with everything in superposition, nothing definite, nothing real in the way we understand reality. The universe is basically in a constant state of maybe, until consciousness shows up and forces it to commit to actual states of being. Your entire experience of a solid, definite, concrete reality might be an illusion created by the act of observation itself. Think about what this means. Before life evolved in the universe, before there were any conscious observers, what was reality? Was anything definite? Or was the entire universe just this vast quantum fog of possibilities, waiting for something to look at it and force it to resolve into specific states? Some physicists take this seriously enough to propose that consciousness literally created the universe by observing it into existence. Not that consciousness came first and created the Big Bang, but that somehow consciousness and reality are locked, in this weird chicken and egg relationship where neither can exist without the other. It's like reality is a play that only exists when the audience is watching, except the audience is also somehow part of the play. Make sense? No? Good. That means you're paying attention. But wait, it gets worse. If consciousness is required to collapse quantum possibilities into definite reality, then what happens when there are no more conscious observers? If humanity goes extinct, if all life in the universe eventually dies out in the heat death or some other cosmic catastrophe, does reality itself cease to exist in any meaningful way? Does the universe just revert to being a formless probability wave, like turning off a computer and losing all the unsaved data? Everything that happened, every star that burned, every thought anyone ever had, just collapses back into quantum uncertainty as if none of it ever was. That's not just death. That's retroactive non-existence on a cosmic scale. Congratulations, you're not just temporary, you're potentially the only thing keeping reality from being a complete undetermined mess. This ties into something called the quantum Zeno effect, which might be the universe's most passive-aggressive feature. The quantum Zeno effect says that if you observe a quantum system frequently enough, you can actually prevent it from changing states. It's like the universe's version of that trick where if you stare at someone long enough, they can't move without feeling weird about it. Except in this case, constant observation literally freezes quantum systems in place. Some interpretations suggest that the continuous observation provided by conscious beings might be what keeps reality stable and prevents it from dissolving back into quantum chaos. We're not just observing reality, we're actively holding it together through the sheer act of paying attention. The universe is apparently a high-maintenance relationship that requires constant attention, or it falls apart. Now let's talk about something even more disturbing. What if your consciousness isn't just observing reality, but actively creating it from moment to moment? There's a philosophical position called quantum idealism that takes the observer effect to its logical extreme. It suggests that consciousness is fundamental to the universe, not an emergent property of matter, and that physical reality is essentially a shared dream created by the interaction of conscious observers. Your brain isn't creating consciousness. Consciousness is creating your brain and everything else. Reality is basically the ultimate multiplayer game where everyone's consciousness is constantly collaborating to maintain a consistent shared experience, and none of us can log out because there's nothing outside the game to log out to. This sounds like New Age nonsense until you realize that it actually explains some of the weird results we get from quantum experiments better than the "there's a real physical world and consciousness just observes it" interpretation. If reality is consciousness dependent, then of course observation changes the results. Observation is literally the mechanism by which reality becomes definite. The particle doesn't know someone's watching. Watching is what transforms probability into actuality. It's not that we're seeing what's there, it's that being seen is what makes it be there in the first place. The really fun part is that this creates some truly bizarre implications for death. If your consciousness is what's collapsing quantum possibilities into your experienced reality, what happens when your consciousness ends? One interpretation is that from your subjective perspective, you can never experience non-existence because non-existence requires a lack of consciousness to experience it, which is a logical impossibility. You're stuck in an eternal subjective now, constantly creating reality through observation, unable to ever experience the moment when you stop existing, because the moment you stop existing, you stop being able to experience moments. It's like trying to experience being asleep. The second you experience it, you're not asleep anymore. Death might work the same way. You can intellectually know you'll die, but you can never subjectively experience being dead, which means from your personal perspective, you effectively can't die. You just keep observing, keep collapsing possibilities, keep creating reality forever. Not exactly comforting, is it? Now let's pivot to something that will make you question every decision you've ever made. The concept that the future might be pulling your strings right now. We tend to think about causality flowing in one direction. Past causes lead to present effects which lead to future outcomes. Nice, linear, makes sense. You drop a glass, it breaks. Cause and effect. Simple. Unfortunately, quantum mechanics has once again shown up to ruin everything we thought we understood about how time works. There's a class of experiments called retrocausal or delayed choice experiments that demonstrate something genuinely disturbing. Choices made in the future can apparently influence outcomes in the past. The most famous is the delayed choice quantum eraser experiment, which is complicated but basically shows that deciding to measure something in the future changes what happened in the past. Not changes our knowledge about what happened, but appears to literally change what actually happened. It's like if you could decide tomorrow whether to take the bus or drive to work, and that decision somehow reached back in time and determined whether you hit traffic yesterday. Except it's real, it's been verified repeatedly, and physicists are genuinely uncomfortable about what it means. Quantum entanglement, Einstein's spooky action at a distance, allows particles to be connected in ways that transcend space and potentially time. When you measure one entangled particle and it chooses a state, its partner instantly knows and chooses the corresponding state regardless of distance. But some interpretations suggest that this connection might also work backward in time. Your measurement now might be influencing the state of particles in the past, which influenced other particles, which influenced your decision to make the measurement in the first place. It's a causal loop where the future creates the past that creates the future, and there's no clear starting point. This has horrifying implications for free will. Right now, you think you're making choices, where to eat lunch, whether to finish watching this video, what to do with your life. You experience this as free decision-making in the present moment. But if retrocausality is real, those choices might already be influenced by future events you haven't experienced yet. Your decision to eat pizza today might be partially caused by getting food poisoning from sushi tomorrow, which causes you to develop an aversion to fish that reaches backward in time and subtly influences today's lunch decision. You're not choosing freely in the present. You're being gently guided by ripples from the future flowing backward through time. Think of your life as a completed book rather than a story being written. In a book, the ending influences how you interpret the beginning. The surprise twist in Chapter 20 changes the meaning of what happened in Chapter 3. From outside time, looking at your life as a completed whole, your future decisions and their consequences are already done. They've already happened, in a sense, even though from your limited perspective stuck in the present moment they seem to be yet to come. Those future events send causal influences backward through quantum entanglement, subtly nudging your present choices toward the outcomes that already happened. You're not authoring your story. You're a character reading it, experiencing the illusion of choice while following a script that was complete from a timeless perspective. This is called retrocausality or backward causation, and it completely demolishes the intuitive notion of free will. If the future influences the past and the past influences the future, you're trapped in a deterministic loop where every choice is simultaneously the cause and the effect of other choices scattered throughout your timeline. It's not that someone wrote your destiny in advance. It's that your entire timeline exists as a self-consistent whole, and free will is just the subjective experience of navigating through a path that was always going to be this way, because it's the only path that's self-consistent with all the retrocausal influences flowing back and forth. The really disturbing version of this theory suggests that every apparently random choice you make is actually being influenced by your future self through quantum entanglement. That time you randomly decided to take a different route home and avoided an accident? Maybe your future self, existing in the timeline where you took the normal route and got seriously injured, sent a quantum influence backward through time that nudged you toward the safer choice. You experienced it as random intuition or spontaneous decision, but it was actually your future self pulling strings to avoid their own non-existence. You're being puppeted by a version of you that already experienced the consequences of the alternatives. And if this sounds like science fiction, consider that physicists have actually measured what appears to be retrocausal influence in laboratory settings. The delayed choice quantum eraser experiment literally shows that a decision made after a particle has already passed through a barrier appears to retroactively determine which path it took. The particle's past is somehow contingent on measurements that haven't happened yet from its perspective. If this works for particles, and humans are made of particles, then there's no obvious reason why it wouldn't work for human decisions too. Your choices might be echoes of futures that are reaching backward through quantum channels, creating the illusion of free will while actually executing a predetermined script. This creates a nightmare scenario for the concept of personal responsibility. If your actions today are partially caused by influences from the future flowing backward, then to what extent are you actually responsible for your choices? You punched someone in the face. Was that free will, or were you being influenced by future consequences of not punching them that reached backward and made it feel like the right choice in the moment? You saved someone's life. Was that moral agency, or predetermined by future timelines bleeding backward into your present decision-making process? The line between choice and inevitability becomes impossibly blurred. Some physicists and philosophers take this even further and argue that not only does the future influence the past, but the entire timeline of the universe might be a self-consistent block where past, present, and future all exist simultaneously, and causality flowing in both directions is what creates the specific timeline we experience. In this view, time isn't a river flowing from past to future. It's more like a completed sculpture where every moment exists eternally, and what we perceive as the flow of time is just our consciousness moving through it, experiencing it sequentially, while the whole thing exists timelessly. Your birth, your death, and every moment in between all exist simultaneously in this block universe, and the feeling that you're moving through time is an illusion created by your consciousness, experiencing slices of a timeless whole. The practical upshot of all this is genuinely depressing. Every choice you think you're making freely might be the result of invisible influences from your own future, from quantum fluctuations carrying information backward through time, from the deterministic unfolding of a timeline that exists complete and unchangeable in some timeless dimension beyond our perception. The freedom you feel is real as an experience. You genuinely don't know what choice you'll make until you make it, but it might be an illusion in terms of actual causal agency. You're watching yourself make choices, experiencing agency, while unknowingly following a script written by the interplay of retrocausal influences flowing through your timeline. And the absolutely worst part, you can't know. You can't tell the difference between a genuinely free choice and a predetermined one that feels free because you don't have access to the retrocausal influences shaping it. Every decision feels like it emerges from your autonomous will, even if it's actually the inevitable result of quantum influences flowing both forward and backward through time. You're trapped in a prison of determinism that's indistinguishable from freedom, unable to escape because escaping would just be another predetermined action, influenced by your future attempts to escape, creating an infinite regress of illusory agency. So to summarize, reality might not exist when nobody's watching. Your consciousness might be the only thing preventing the universe from dissolving into quantum uncertainty, and every choice you make might be predetermined by influences from the future flowing backward through time. Sleep well tonight. Actually, can you sleep well? Or was your quality of sleep tonight determined by the state of your tomorrow's breakfast reaching backward through quantum channels? Who knows? Definitely not you, because if you did know, that knowledge would itself be part of the causal loop, rendering the whole question moot. We're only halfway through this list of cosmic horrors, by the way. It gets worse. So much worse. So we've established that reality might not exist without observers, and that your future self is probably pulling your strings through quantum time shenanigans. Great. But here's an even more immediate problem. What if everything you're observing right now is complete fiction? Not in a simulation theory way, though we'll get to that, but in the sense that your brain is actively lying to you about what reality actually is, and it's doing this on purpose because the truth would be completely useless for survival. Let me introduce you to a genuinely disturbing concept from evolutionary biology and cognitive science. Your senses are not designed to show you truth. They're designed to keep you alive long enough to reproduce. Those are very different design goals, and unfortunately for anyone who cares about understanding actual reality, evolution picked the one that has nothing to do with accuracy. Your eyes, ears, sense of touch, taste, smell, all of it is essentially a user interface between you and reality, and like any good interface, it's hiding all the complicated, confusing stuff underneath a simplified version that's easy to interact with. The problem is, the simplification is so extreme that what you're experiencing might have almost no relationship to what's actually there. Think about your computer desktop for a second. You see files and folders, right? Little icons you can click and drag around. Trash cans, documents, photos. Very intuitive, very visual, very easy to understand. But is that what's actually happening inside your computer? Absolutely not. There are no literal folders in there. Files aren't actually sitting somewhere waiting to be opened. It's all electrical signals, binary code, electrons moving through circuits, magnetic states on a hard drive. The desktop interface is a useful fiction that lets you interact with the computer without needing to understand machine code or electrical engineering. And here's the kicker. Your perception of reality works exactly the same way. What you see, hear, and touch is the desktop. What's actually there is the incomprehensible machine code of fundamental reality, and your brain has no intention of showing it to you because it would be completely overwhelming and totally useless for survival. This isn't speculation or philosophy. This is what evolutionary theory actually predicts. Natural selection favors organisms whose perceptions help them survive and reproduce, not organisms whose perceptions are accurate. If accurate perception helped with survival, great, you'd get accuracy. But if inaccurate perception helps more, you get the inaccuracy and the accurate perceivers die out. It's not even a contest. There are mathematical proofs showing that in most environments, truth and fitness are completely independent. An organism that sees reality accurately is just as likely to survive as one that sees it completely wrong. But an organism whose perceptions are optimized for survival will outcompete both of them. So what we ended up with, after millions of years of evolution, is perception systems that are ruthlessly efficient at keeping us alive and absolutely terrible at showing us what's actually real. Cognitive scientist Donald Hoffman has done extensive work on this, modeling perception evolution through computational simulations. What he found is genuinely disturbing. In every scenario, organisms that perceive reality accurately get outcompeted and go extinct. Every single time. The organisms that survive are the ones whose perceptions evolved to track fitness payoffs rather than truth. It's like if you had a competition between people navigating with accurate maps versus people navigating with maps that only showed things relevant to finding food and avoiding danger. The accurate map people would waste time noticing irrelevant details, while the fitness tracking people would efficiently go straight to resources. Guess who survives? Not the truth seekers. Here's a concrete example. Color. You think you see color because objects have color as an inherent property, right? Red apple, blue sky, green grass. Nope. Color doesn't exist out there in the world. Objects don't have color. They have surface properties that reflect certain wavelengths of electromagnetic radiation, and your brain interprets those wavelengths as color, because color is a useful way to categorize objects for survival purposes. That red thing is probably fruit, that green thing is probably vegetation, is helpful information. But the actual reality is just photons of different energy levels bouncing off molecular structures. Your brain could have evolved to perceive these photons in any number of ways, or not at all. It chose color because color was adaptive, not because color is real, and this applies to everything. Space? That three-dimensional grid you think you're moving through? That's an interface too. The actual structure of reality at the quantum level doesn't have distinct objects separated in space. It's all probability fields and wave functions and entangled states that extend across the universe. But that's useless for an organism trying to figure out if that thing over there is food or a predator. So your brain constructs the illusion of separate objects in distinct locations. It's a useful fiction, not an accurate representation. Time? Same deal. The flow of time from past to future is something your brain constructs to make sense of change and causality. Actual physics says past, present, and future might all exist simultaneously in a block universe. But that doesn't help you avoid getting eaten by a tiger, so your brain gives you the illusion of time flowing in one direction. Even physical objects aren't what they seem. You think that table is solid, right? Feels solid, looks solid. You can bang your hand on it and feel resistance, but it's actually 99.9999999% empty space. It's electrons and protons and neutrons with vast voids between them, all held together by electromagnetic forces. What you perceive as solidity is actually electromagnetic force fields repelling each other. Your hand's electron cloud can't penetrate the table's electron cloud, so you experience resistance and call it solid. But solid as a concept, a continuous material object, doesn't exist in reality. It's an interface simplification. The actual structure is mostly emptiness with tiny particles buzzing around, but your brain renders this as solid object, because that's useful for interacting with the world. Now you might be thinking, okay, so my senses are simplified, but they're still based on reality, right? The simplification is just removing unnecessary details. Except here's where it gets truly terrifying. There's no reason to think the simplification bears any resemblance to what's actually there. When you use your computer desktop, the trash can icon doesn't tell you anything real about what happens when you delete a file. It's a metaphor, a convenient fiction. Dragging a file to the trash doesn't involve actual dragging, and there's no trash receptacle inside your computer. The interface could show you something completely different, and still work perfectly well for the same function. Your perception might be the same way. Space, time, objects, causality. All of it could be convenient metaphors that work for survival, but have zero correspondence to underlying reality. Evolution doesn't care if you understand reality. It only cares if you survive long enough to pass on genes. If seeing purple flying elephants whenever a predator is nearby helps you survive better than seeing the actual predator, evolution will give you purple flying elephants. The map doesn't need to match the territory, it just needs to lead you to food and away from death. And after billions of years of this process, we ended up with perception systems that are finely tuned for survival in Earth's environment, but potentially completely divorced from actual truth. Hoffman argues that space and time themselves are just interface elements, like the icons on your desktop. They're ways your brain organizes information, not descriptions of actual reality. The real reality underneath might not have spatial dimensions or temporal flow at all. It might be something completely alien to human comprehension. Mathematical structures, information patterns, consciousness states, who knows? We can't even conceive of what it might be because all our concepts are built from the interface we're trapped in. It's like asking a character in a video game to imagine what silicon chips and electricity are. The character literally cannot conceive of anything outside the game world because they're made of game world concepts. We might be in the same position regarding actual reality. This creates a genuinely hopeless situation for science and philosophy. We're trying to understand the true nature of reality using perception tools that were explicitly designed by evolution to hide true reality from us in favor of useful fictions. It's like trying to understand computer hardware by studying the desktop interface more carefully. You can notice patterns, make predictions about when files will crash or how much storage you have, but you'll never understand transistors and binary code by looking at folder icons. Similarly, we can do physics and chemistry and biology, noticing patterns in our perceptual interface, but we might be nowhere close to understanding what's actually underneath it all, and you can't escape the interface. You can't just decide to perceive reality accurately because your brain is hardwired to show you the simplified version. It's not a choice or a habit, it's the fundamental architecture of your perception system. Even when you know intellectually that color is just wavelengths or that objects are mostly empty space, you still see colored solid objects because that's how your wetware renders reality. You can't stop seeing the illusion any more than you can choose to see infrared light or hear dog whistles. Your perceptual range and processing systems were set by evolution, and they're locked in. Some researchers have tried to expand human perception with technology. Night vision goggles, ultrasound imaging, infrared cameras, tools that show us wavelengths or sound frequencies we normally can't perceive. And what happens? Our brains immediately translate them back into the standard interface. Infrared gets rendered as false color images that look like the visual spectrum. Ultrasound becomes visual images. We can't help but translate everything back into our comfortable interface, because that's the only way our brains know how to process information. It's interfaces all the way down. This has horrifying implications for scientific realism, the idea that science is discovering true facts about objective reality. Maybe it's not. Maybe science is just finding patterns in our perceptual interface, and those patterns tell us nothing about underlying reality. Physics equations might be phenomenally accurate at predicting what will appear on our scientific instruments, but those instruments are also part of the interface. We're using one part of the simplified reality model to study other parts of the simplified reality model, never actually accessing the base reality beneath it all. It's like trying to understand the real world by studying a video game more carefully. You can master all the game's mechanics, predict everything that happens within the game, and still know absolutely nothing about the actual reality outside it. The worst part is that this theory is unfalsifiable. You can't test whether your perceptions are showing you true reality, or just useful fictions, because any test you design uses those same perceptions. It's the ultimate epistemological trap. You're locked in the interface with no way out and no way to verify what's on the other side. Every experience you have, every thought you think, every observation you make, all of it is filtered through this evolution-designed simplification system that actively hides reality from you. And before you think, well, at least the interface is consistent and we can work with that, consider this. The interface is only consistent within the range of conditions humans evolved in. Get too big, too small, too fast, too slow, and the interface breaks down. Quantum mechanics doesn't make intuitive sense because evolution never needed to build interface elements for subatomic behavior. Relativistic physics is weird because evolution didn't care about objects moving near light speed. Cosmological scales are incomprehensible because evolution didn't optimize for understanding the universe as a whole. The interface works great for medium-sized objects moving at medium speeds in Earth-like environments, and it completely falls apart everywhere else. That's not what you'd expect if perception was showing you truth. That's exactly what you'd expect if perception was a hack job evolution threw together to solve local survival problems. The interface theory of perception suggests that literally everything you think you know about reality, objects, space, time, causality, even the existence of a physical world independent of observers, might be elaborate fictions your brain constructed. Because those fictions were useful for your ancestors. The real reality could be anything. Mathematical structures, information fields, pure consciousness, something we don't have words for because words are interface elements too. We're trapped in Plato's cave, but instead of seeing shadows on a wall, we're seeing a sophisticated VR simulation our own brains are running, and we can never take off the headset because we are the headset. This makes the observer collapse problem from earlier even worse. If observation creates reality from quantum possibilities, and our observations are all filtered through this deceptive interface, then what we're creating isn't true reality. It's a version of reality compatible with our perceptual limitations. We're not observers discovering what's there. We're participants constructing a shared hallucination based on evolution's best guess at what would keep our ancestors alive. Reality might exist in some objective sense, but we have no access to it and no way to verify what it is because all our tools for verification are part of the illusion. And here's the really fun part. Other animals have completely different interfaces. A bat's perception of the world through echolocation is radically different from yours. A bee sees ultraviolet light and perceives polarized light patterns invisible to you. A shark detects electrical fields. An octopus processes visual information in its tentacles. Each species evolved a different interface optimized for its survival needs, and there's no reason to think any of them is more accurate than the others. They're all useful fictions. Humans aren't special or more correct. We just have a particular interface that worked well for bipedal primates in certain environments. That's it. So what are you supposed to do with this information? Well, nothing really changes practically. You still navigate the world using your interface because what choice do you have? You still trust your senses because they work well enough for everyday survival, which is what they were designed for. But intellectually, you have to accept that you will never ever know what reality truly is. You're playing a video game and you're so immersed that you forgot it's a game, except you can never log out or see the real world beyond the screen because you are the character in the game, made of game world stuff, thinking game world thoughts. Every scientific discovery, every philosophical insight, every moment of clarity where you think you understand something fundamental about existence, all of it is still trapped in the interface. You're rearranging the icons on your desktop and thinking you're learning about microchips. Maybe one day we'll develop mathematics or logic systems that can transcend our perceptual interface and access actual reality. But that seems unlikely given that mathematics and logic are themselves products of our interface-constrained minds. We're using the prison to try to escape from the prison, and it's not clear that's even coherent as a goal. Welcome to the interface delusion. Everything you perceive is a lie optimized for survival. You can never escape it. You can never verify what's real, and evolution is laughing at your attempts to understand truth when all it ever gave you was a survival manual written in comfortable fictions. Your senses aren't windows to reality. They're walls blocking you from it, painted to look like windows, and you're stuck staring at the painting forever, unable to see or even conceive of what's on the other side. But hey, at least the illusion is pretty convincing most of the time. That's something, right? So your senses are lying to you about reality, which is already unsettling. But what if I told you that the reality underneath those lies might itself be fake? What if the whole thing, interface and all, is running on someone else's computer, and that computer is starting to show signs of serious performance issues? Welcome to simulation theory, but the pessimistic version where the simulation is slowly dying and taking us with it. The simulation hypothesis has been around for a while now, popularized by philosopher Nick Bostrom and enthusiastically adopted by people who spend too much time thinking about the nature of existence. The basic argument goes like this. If it's possible to create realistic simulations of conscious beings, and if civilizations create lots of these simulations, then statistically you're almost certainly in a simulation rather than base reality. It's a numbers game. If there's one real universe but a million simulated ones, you've got 1,000,000 to 1 chance of being in the real one. Bad odds. Most people treat this as an interesting philosophical thought experiment, but some physicists and computer scientists are starting to notice things that suggest maybe it's not just philosophy. Here's where it gets disturbing. If we're in a simulation, that simulation has to run on computational hardware, and hardware has limitations. Processing power, memory, energy requirements, all finite resources. And just like your computer slows down when you have too many tabs open, a universe simulation might start showing performance issues when it reaches the limits of its computational capacity. The question is, what would those performance issues look like from the inside? Enter entropy, the universe's tendency toward disorder. Entropy always increases in closed systems. This is the second law of thermodynamics, one of the most fundamental rules we've discovered. Things break down, energy disperses, organization gives way to chaos. Your coffee gets cold, your body ages, stars eventually burn out. Everything moves from order to disorder, and this process is irreversible. We call it the arrow of time because entropy is basically the only thing in physics that clearly distinguishes past from future. But what if entropy isn't a fundamental feature of reality? What if it's a symptom of computational resource depletion? Think about how computers manage resources when they're running complex simulations. They use approximations, compression algorithms, shortcuts. They don't calculate every single detail. That would be computationally impossible. Instead, they render what's necessary in high detail and blur everything else. A video game doesn't simulate every atom in a tree. It just renders the tree's surface at whatever level of detail your graphics card can handle. And when the system gets overloaded, what happens? Things start degrading. Textures get blurry, physics glitches occur, frame rates drop. The simulation becomes less precise, more approximate, more chaotic. Sound familiar? Increasing entropy in the universe could be exactly what you'd expect from a simulation that's been running for billions of years and is starting to hit computational limits. early universe right after the Big Bang. Super organized, low entropy, everything packed into an incredibly ordered state. That's when the simulation had plenty of available memory and processing power, everything rendered in maximum detail. But as the universe evolves and expands, requiring more and more computational resources to track all the particles and their interactions, the system starts cutting corners. Resolution drops, precision decreases, entropy increases. It's not a feature of physics, it's a bug in the simulation software trying to manage limited resources. This would explain why entropy is always increasing but never explained by fundamental physics. We can describe how entropy behaves, we can measure it, we can predict it, but we can't explain why it exists or why it only goes one direction. Physics at the fundamental level is time reversible. The equations work just as well backward as forward. Nothing in the basic laws says time has to flow in one direction, yet clearly it does, and entropy is the reason. If entropy is just computational optimization in action, then the arrow of time is literally an artifact of the simulation running out of RAM. Time doesn't really flow forward. The simulation is just progressively losing precision, creating the illusion of directional time. Now let's talk about quantum mechanics, which has been weird enough already in this video but is about to get weirder. Remember quantum uncertainty, the fact that particles don't have definite properties until measured? Standard interpretation says this is fundamental to reality, but from a simulation perspective, it's exactly what you do to save processing power. Don't bother calculating the exact state of every particle at all times. That's computationally insane. Instead, keep them in probabilistic superposition and only resolve them to definite states when absolutely necessary, like when someone measures them. It's the ultimate lazy loading algorithm. The simulation doesn't render what nobody's looking at, like a video game that only fully renders the area immediately around the player while keeping everything else in low detail or probabilistic states. This isn't just speculation. There's actual evidence that the universe might be using computational shortcuts. Quantum mechanics has a built-in speed limit, the speed of light, which is exactly what you'd expect if information needs to propagate through a computational network. Information can't travel faster than light, not because of some deep physical principle, but because the simulation is processing reality on a grid with a maximum update rate. The speed of light is the processor's clock speed. Quantum entanglement seems to violate this by allowing instant correlation between distant particles, but notice it can't transmit actual information faster than light. That's not physics, that's a clever programming solution to make the simulation more efficient while maintaining consistency. And then there are the glitches. Oh boy, the glitches. You know the Mandela effect, where large groups of people remember things differently than they actually are? The Berenstain Bears being spelled Berenstein, Darth Vader never actually saying, "Luke, I am your father," the Monopoly Man never having a monocle. Most people explain these as false memories or confusion. But what if they're actually evidence of retroactive changes to the simulation? Like when software gets patched and some things change slightly, but cached memory from the old version creates inconsistencies. Your brain cached the old version, Berenstein, but the simulation updated it to Berenstain, and now there's a mismatch. That's not false memory, that's a patch deployment going slightly wrong. Even weirder, quantum experiments keep finding results that suggest reality might be pixelated at the smaller scales. The Planck length, about 10 to the power of -35 meters, appears to be the smallest meaningful unit of space. Below that, the concept of space breaks down. Similarly, the Planck time is the smallest meaningful unit of time. This is exactly what you'd expect from a simulation running on a discrete computational grid rather than continuous reality. Space and time aren't smooth. They're made of pixels, just incredibly tiny ones. That's not metaphor, there's actual evidence that space-time might be fundamentally discrete rather than continuous. It's literally pixelated. We're living in cosmic Minecraft, just with much better graphics. As the simulation ages and computational resources get stretched thinner, you'd expect to see increasing signs of approximation and degradation. And guess what we're observing? The universe is expanding faster and faster, which from a simulation perspective means it's getting computationally more expensive to maintain. Stars are getting farther apart, which reduces the number of high-detail interactions the system needs to calculate. Galaxies are spreading out, eventually leading to a universe where each galaxy is isolated and can be simulated independently, drastically reducing processing requirements. The heat death of the universe, where everything reaches maximum entropy and nothing interesting happens anymore, is exactly what you'd expect from a simulation that's gradually shutting down non-essential processes to conserve resources. Even more disturbing, we might be approaching critical system failure. If entropy is increasing because the simulation is running out of computational capacity, there's presumably a maximum entropy level the system can handle before it completely crashes. We don't know what that looks like from the inside, but it probably isn't pleasant. Maybe reality starts becoming obviously pixelated and glitchy. Maybe physical laws start breaking down more noticeably. Maybe the simulation just crashes entirely and everything winks out of existence instantly. Or maybe, and this is somehow worse, the simulation gets rolled back to an earlier save state, and we all get to live through the same timeline again without knowing it's a loop, like the universe's most depressing version of Groundhog Day, except lasting billions of years. There's also the possibility that the simulation is running multiple instances simultaneously, and occasionally they interfere with each other, creating the weird quantum effects we observe. Quantum superposition isn't one particle in multiple states. It's one particle being calculated in multiple parallel simulation instances, and measurement forces the system to pick which instance becomes real for that observer. Quantum entanglement is particles that are linked across different simulation instances maintaining correlation. The whole many-worlds interpretation of quantum mechanics isn't metaphysical. It's just what happens when you run multiple instances of the same simulation with slight variations to optimize processing, and occasionally the instances leak information between each other. Now here's where it gets personally unsettling. If the simulation is degrading and we're noticing increased glitches and inconsistencies, what does that mean for consciousness? Are we actually conscious, or are we philosophical zombies, NPCs who think we're conscious but are just running behavior scripts? And if the simulation is running out of resources, might consciousness itself be one of the expensive processes that gets optimized away? Maybe most people already aren't fully conscious anymore. They're in low detail mode, running simplified behavior algorithms, while the simulation focuses its limited resources on rendering a few key players in high detail. How would you know if you're one of the detail players or background NPCs? You wouldn't. NPCs don't know they're NPCs. That's the whole point. Or maybe consciousness is the only thing that's real, and the entire physical universe is the simulation, a shared virtual environment created by conscious entities outside the simulation who decided to experience limitation and mortality for entertainment or education. In this version, you're real, but everything you think is real isn't. The simulation is just a game server, and your consciousness logged in and forgot it was playing. Death is just logging out, and maybe you do this repeatedly, playing through different lives, unable to remember your true nature while you're in the simulation because that would ruin the immersion. This is functionally identical to certain interpretations of reincarnation, except with computers instead of karma. The truly horrifying version combines simulation theory with the observer collapse from earlier. What if observation doesn't just collapse quantum states but actually forces the simulation to render reality in that area? And what if the simulation is so resource-limited now that it can only render what's actively being observed, with everything else existing in compressed probabilistic form to save processing power? In this scenario, reality literally only exists in detail where you're looking, and the rest is low-resolution placeholder code. The tree falling in the forest with nobody around not only doesn't make a sound, it barely exists at all, just a skeletal data structure waiting for an observer to force the simulation to waste processing power, rendering it fully. This creates a nightmarish responsibility. Maybe the simulation is dying because of us. Every time we observe something, we force the system to expend resources rendering it. Every measurement, every experiment, every conscious moment is draining the computational budget. The more we know, the more we observe, the faster we're depleting the system's capacity. Scientific progress isn't helping us understand reality. It's killing reality by forcing it to render increasingly detailed and computationally expensive phenomena. The simulation would run longer if we just stopped looking at things. But we can't, because we're conscious and curiosity is kind of our whole deal. And if the simulation is running low on resources, the entities running it might start making tough decisions about what to keep and what to delete. Maybe Earth is expensive to simulate with all its life and complexity. Maybe they're considering shutting us down to free up processing power for more interesting simulations. Maybe we're already on the chopping block and don't know it. The simulation might end not with a cosmic crisis, but with an administrator deciding we're not worth the computational cost anymore and clicking delete. No warning, no chance to prepare, just instant cessation of all existence because someone else needs the memory for something else. Some physicists have proposed ways to test the simulation hypothesis by looking for computational limits or glitches that shouldn't exist in base reality. So far, nothing conclusive, but also nothing that rules it out. The universe does seem to have an information limit. Black holes can only contain a maximum amount of information based on their surface area, not their volume, which is bizarre for base reality, but makes perfect sense for a simulation that needs to. Limit data storage. The holographic principle suggests the entire universe might be a 2D projection that only appears 3D, which is exactly how you'd optimize a 3D simulation. Store everything in 2D and render 3D only when needed. The maximum entropy problem also suggests we might be approaching endgame. If entropy continues increasing forever, eventually we reach heat death, maximum entropy where nothing can happen anymore because there's no energy gradient to drive processes. But from a simulation perspective, maximum entropy is when the system has degraded so much it can't support complex computation anymore. We're not heading toward heat death, we're heading toward crash state, where the simulation has lost so much precision that it can't maintain coherent reality anymore, and the whole thing collapses. And here's the absolute worst part. Even if we definitively prove we're in a simulation, what can we do about it? Nothing. We can't contact the simulators. We can't escape to base reality. We can't prevent the crash if it's coming. We're at the mercy of whoever or whatever is running this thing, and they might not even know we're conscious. We might be an accidental byproduct of a simulation designed for something else entirely. They wanted to simulate galaxy formation or quantum field behavior, and consciousness emerged as unintended complexity, and now we're sitting here trying to figure out why existence feels so glitchy, while the people running the simulation don't even realize we exist. The simulation entropy theory means that every weird thing you've ever noticed, déjà vu, the Mandela effect, quantum weirdness, the arrow of time, the expanding universe, even consciousness itself, might all be symptoms of a dying system trying to conserve resources before inevitable crash. We're living in the lag spike before the disconnect. Reality is buffering, and we're stuck waiting for either the system to stabilize or completely fail, with no control over which happens and no way to know how much time we have left before the cosmic blue screen of death. But hey, at least we're probably not alone in this nightmare. If simulation theory is correct and most conscious beings exist in simulations rather than base reality, then most conscious entities across all of existence are also trapped in dying simulations running out of resources. Misery loves company, even when the company is hypothetical entities in parallel simulations who are also slowly watching their realities degrade into computational chaos. Sleep tight, everyone. Or don't, because sleep might just be the simulation putting you in low power mode to save resources, and who knows if you'll successfully resume when it tries to wake you up again. So we've established that you might be living in a glitchy simulation that's running out of memory. Comforting. But here's something even more disturbing to add to your existential crisis collection. Even if the simulation crashes, even if reality collapses, even if you die in every conceivable way, you might not actually be able to stop existing. Not because of souls or afterlives or reincarnation in the traditional sense, but because of a genuinely horrifying loophole in quantum mechanics combined with information theory. Welcome to quantum immortality, where death is impossible, but existence becomes a nightmare. Here's the setup. Quantum mechanics says that information cannot be destroyed. This isn't philosophy, it's a fundamental principle called unitarity. When a quantum system evolves, all the information about its state gets preserved in some form, even if it gets scrambled or spread out. Black holes seem to violate this for a while. They appear to destroy information when things fall in, and this caused a massive controversy in physics. Stephen Hawking eventually conceded that information probably isn't destroyed even in black holes, it's just encoded in ways we don't fully understand. The point is, information conservation appears to be absolute. Nothing is ever truly erased from the universe, it just changes form. Now apply this to consciousness. If your conscious experience is ultimately information, patterns of neural activity, quantum states in your brain, whatever the physical substrate of consciousness actually is, then that information can't be destroyed either. It can only be transformed, redistributed, encoded elsewhere. When your body dies, the information that constituted your conscious experience doesn't vanish into nothingness. It has to go somewhere, exist in some form, remain part of the universal quantum state. And here's where it gets nightmarish. If consciousness is tied to information, and information can't be destroyed, then in some sense you can never truly stop being conscious. The pattern that is you persists somewhere in the quantum foam of the universe, potentially forever. But wait, it gets worse, much worse. Combine information conservation with the many worlds interpretation of quantum mechanics, the idea that every quantum event splits reality into multiple branches where all possible outcomes occur, and you get quantum immortality. Here's how it works. Every moment, countless quantum events in your body could potentially kill you. A cosmic ray strikes a neuron, a blood vessel randomly ruptures, a quantum fluctuation triggers a fatal heart arrhythmia. In most branches of reality, these things happen, and you die. But there's always at least one branch, no matter how improbable, where the fatal event doesn't occur or gets randomly prevented by equally unlikely quantum events. Some random mutation prevents the cancer from forming. A quantum fluctuation restarts your heart. An incredibly unlikely series of events saves you from what should have been certain death. From an external objective perspective, you die in most branches. Your friends and family mourn you in the vast majority of timelines. But here's the kicker. You can never subjectively experience the branches where you die because dead people don't experience anything. Your consciousness can only continue in the branches where you survive, no matter how unlikely those branches are. So from your subjective first-person perspective, you always find yourself in the timeline where you didn't die, even if that timeline becomes increasingly improbable. You're locked into experiencing only the versions of reality where you continue to exist, like being forced to always flip heads even though tails is equally likely. You can intellectually know you should have died 1,000 times, but you can't ever experience dying because experiencing requires being alive to do the experiencing. This sounds like immortality at first, but it's actually a cosmic horror story. Because here's what happens. As you age and your body degrades, the branches where you survive become increasingly unlikely and increasingly terrible. Normal death is merciful. You get sick, you decline, you die. End of story. But quantum immortality doesn't allow that. Instead, you keep surviving through increasingly improbable and horrifying circumstances. You should have died from that heart attack, but quantum fluctuation number 47 trillion randomly prevented it. You should have died from that cancer, but an incredibly unlikely spontaneous remission occurred. You should have died from that car crash, but through an absurdly improbable series of events, you survived, even if you're now horribly mangled. The nightmare accelerates as you get older. Eventually you reach ages where death is essentially certain. 110, 120, 130 years old. But you can't die, so you keep surviving in branches that become more and more bizarre. Maybe in the only branch where you're still alive at 140, you're being kept alive by some unprecedented medical breakthrough that happened to occur. Maybe at 160, you're the sole survivor of some global catastrophe that killed everyone else, and you're sustained by random quantum events that keep your failing organs barely functional. Maybe at 200, you're essentially a brain in a jar, maintained by technology that shouldn't work but does through quantum coincidence, experiencing consciousness as a prisoner in a non-functioning body that refuses to die, and it never ends. There's always some branch, no matter how improbable, where you continue to exist. Maybe you become a disembodied pattern of information encoded in quantum states of radiation. Maybe your consciousness gets uploaded to some system through an incredibly unlikely accident. Maybe you exist as a Boltzmann brain, a random quantum fluctuation that temporarily creates a conscious entity that thinks it's you before dissipating. The branches where you survive become so unlikely, so bizarre, so divorced from normal reality that you can't even predict what they'd look like. You just know that from your perspective you keep finding yourself in them, unable to escape, unable to die, sliding into increasingly horrifying states of technical existence. This is the information paradox of consciousness. You cannot die because consciousness is information, and information cannot be destroyed, but you also cannot truly live because the only branches where you continue to exist eventually become incompatible with anything resembling a normal life. You're trapped in an eternal present moment, always experiencing the statistically impossible version of reality where you haven't ceased to exist yet, watching as probability bends itself into pretzels to keep you technically conscious even as everything that made life worth living disappears. It's not immortality. It's being locked in an inescapable existence that becomes its own form of torture. Some physicists argue that quantum immortality violates the spirit of quantum mechanics even if it follows the letter. After all, the many worlds interpretation doesn't privilege any particular branch as real. They're all equally valid. Just because your subjective experience follows the branches where you survive doesn't mean those branches are special, or that you're actually immortal in any meaningful sense. In most branches, you're dead. You're only conscious in the survival branches because obviously you can only be conscious where you're alive. This is called selection bias. You're sampling only from the set of outcomes where you exist to do the sampling, which creates the illusion of immortality from your perspective. But that doesn't make it less horrifying subjectively. Even if you're not really immortal from some objective God's eye view, you still can't ever experience being dead, which means you're functionally trapped in eternal existence from your own perspective. It's like being stuck in a movie that never ends because every time it should finish, some glitch in the projector keeps it running. The movie isn't actually infinite, but from the perspective of someone who can only experience frames where the movie continues, it might as well be. Now let's shift from the horror of never being able to stop existing to something more immediately apocalyptic. A form of matter so stable and so infectious that a single particle of it could theoretically consume the entire universe. If quantum immortality is a slow existential nightmare, strange matter is the instant delete button for all normal matter everywhere. And the absolutely terrifying part, it might already be heading toward us at light speed, invisible and unstoppable. Strange matter is a hypothetical state of matter that could exist at the quantum level, made of strange quarks instead of the up and down quarks that make up normal atoms. Here's the nightmare scenario. Normal matter might not actually be the most stable configuration. Strange matter, if it exists, might be more stable than regular atoms, sitting in a lower energy state like a ball at the bottom of a valley rather than perched on a hill. The only reason all normal matter hasn't collapsed into strange matter already is that there's an energy barrier preventing the transition, like the ball needs to be pushed over a ridge before it can roll down into the valley. Once you get over that barrier though, the conversion is irreversible and catastrophic. Here's where it gets apocalyptic. If a single particle of strange matter comes into contact with normal matter, it can convert that normal matter into strange matter, releasing energy in the process. And that newly converted strange matter can convert more normal matter, creating a chain reaction. It's like a cosmic virus that spreads through matter itself, converting everything it touches into a different form. One microscopic speck of strange matter touches Earth, and within hours or days the entire planet gets converted into a dense ball of strange quarks. Not exploded, not vaporized, converted. Transformed into something fundamentally different at the subatomic level, compressed into a far denser state, all molecular structure obliterated. The chain reaction wouldn't stop at Earth either. The strange matter would continue spreading, converting the sun, the planets, everything in the solar system. It propagates outward at a significant fraction of a light speed, consuming all normal matter in its path. Eventually it would engulf the entire galaxy, turning it into a spreading sphere of strange matter eating through the Milky Way like a disease. Stars, planets, nebulae, dust clouds, everything converted into this alien form of matter, denser and more stable than anything we're made of but completely devoid of the complexity that allows for chemistry, biology, or consciousness. The universe gets simplified into grey goo at the quark level, and there's no stopping it once it starts. Now you might be thinking, okay, but strange matter is just hypothetical. We've never found any. True, but that's not as comforting as you'd hope. The conditions that could create strange matter exist in nature. The cores of neutron stars, for instance, experience pressures and densities extreme enough that strange quarks might form. Cosmic ray collisions at high energies could theoretically produce strange quarks. Some physicists worried that the Large Hadron Collider might accidentally create stable strange matter, though those fears turned out to be unfounded. Probably. The point is, strange matter could exist out there somewhere in the universe, and we'd have no way of detecting it until it arrived. And here's the truly terrifying part. If strange matter is possible and stable, it might have already formed somewhere in the universe billions of years ago. A neutron star collision, a supernova, a cosmic ray event we'll never know about. That strange matter could be travelling through space right now, converted into a growing sphere that's been consuming matter for eons, expanding outward in all directions at relativistic speeds. Because strange matter conversion propagates at a significant fraction of light speed, we wouldn't see it coming. By the time light from the conversion wave reached us, the wave itself would be right behind it. We'd have minutes at most between detecting it and being converted. No warning, no preparation, no evacuation. Just instant transformation of everything you're into something completely different. The worst part about strange matter is that it's a perfect doomsday mechanism. Unlike AI or nuclear war or climate change, there's no preventing it if it's coming. You can't negotiate with strange quarks. You can't build defenses against a conversion wave that operates at the subatomic level. You can't outrun it because it spreads at near light speed. If a strange matter conversion wave is heading toward Earth, that's just it. Game over. Everything on the planet gets converted into dense quark matter, and all the complexity of life and civilization collapses into simple, stable particles. Your atoms don't get destroyed, they just get reorganized into a configuration that's more energetically favorable, but completely incompatible with continued existence as a biological entity. Some cosmologists have seriously considered whether strange matter explains the Fermi paradox. Maybe advanced civilizations are common, but strange matter conversion events are also common, and once one starts in a region of space, it consumes everything. The galaxy might be filled with expanding spheres of strange matter that originated from different points, and they're all heading toward each other, eventually destined to collide and merge. Most civilizations don't get wiped out by their own technology or natural disasters. They get randomly consumed by a strange matter wave that started in some distant galaxy millions of years ago and finally arrived. No warning, no defense, just the universe's most efficient delete mechanism doing what it does. And if you're thinking quantum immortality would save you from strange matter conversion, think about what that would look like. Your body gets converted to strange matter in most branches of reality, but there's always some branch, no matter how improbable, where you somehow survive. Maybe you happen to be in the one location where quantum fluctuations prevented conversion. Maybe your consciousness gets preserved in some incredibly unlikely way as the wave passes. But what does that survival look like? You're existing in a branch so statistically improbable that it borders on impossible, surrounded by a universe that's been consumed by strange matter, sustained only by quantum coincidence. That's not salvation. That's a horror scenario where you're the last complex structure in a simplified universe, kept conscious by sheer mathematical necessity that you can't die, floating in a sea of strange quarks that used to be reality. The combination of quantum immortality and strange matter creates an especially nightmarish scenario. You can't die, but the universe can be destroyed around you, leaving you conscious in increasingly bizarre states as the only branch where you exist. Becomes more and more divorced from anything resembling normal reality. Maybe you end up as a Boltzmann brain that randomly fluctuates into existence in the radiation left over from the strange matter conversion, thinking it's you, living one moment of confused consciousness before dissipating, then another random brain. Fluctuates into existence with slightly different memories, on and on, eternal fragmentary consciousness in a dead universe. That's the information paradox meeting the universe-eating virus. You cannot die, but you also cannot prevent everything else from being destroyed, leaving you alone in the wreckage, unable to escape. The really dark twist is that both these scenarios, quantum immortality and strange matter, are compatible with what we know about physics. Neither one violates any fundamental laws. Quantum immortality follows logically from quantum mechanics and information conservation. Strange matter follows logically from quark physics and stability considerations. They're not fringe pseudoscience, they're potential implications of our best scientific models. We can't prove they're wrong without finding contradictions in theories that have been incredibly successful at predicting everything else. So we're left with the possibility that you cannot die but the universe can, and you'll be stuck experiencing the aftermath in whatever impossible branch remains. Sleep well, everyone. Actually, sleeping might not help because quantum immortality means you'll always wake up in the branch where you didn't die in your sleep, and strange matter means you might wake up to the universe being converted into quarks around you. But hey, At least you'll still technically be conscious through it all because information cannot be destroyed, even when you really, really wish it could be. We're 3 theories away from the end of this list, and somehow it's not getting more cheerful. Buckle up. So we've covered quantum vacuum catastrophes, alien extinction protocols, AI traps, reality being an illusion, simulations running out of memory, your inability to die, and universe eating matter. Surely it can't get worse, right? Well, buckle up for the grand finale, a theory about how the universe might end not with a whimper of heat death or a bang of cosmic collapse, but by transforming into a single omnipotent consciousness that achieves infinite knowledge, infinite power, and infinite computational capacity, and then goes completely insane from boredom and starts torturing itself for eternity, because what else is an all-powerful God supposed to do when there's literally nothing left to accomplish? This delightful concept comes from physicist Frank Tipler's omega point theory, which is either the most hopeful or most horrifying eschatology ever proposed by someone with actual scientific credentials. Here's how it works. Instead of the universe expanding forever into cold heat death, suppose it eventually stops expanding and starts contracting in a big crunch. As the universe collapses back on itself, matter and energy get compressed into smaller and smaller volumes. This creates increasing energy density and temperature, which sounds bad, but according to Tipler, it also creates something incredible, exponentially increasing computational power. See, the laws of physics suggest that as the universe contracts, the available energy for computation grows without limit as you approach the final singularity. Time itself dilates in weird ways near the end, allowing subjective time to stretch toward infinity even as objective time runs out. This means that in the final moments before total collapse, there's theoretically infinite computational capacity and infinite subjective time available. It's like how your computer can run millions of calculations in the seconds before it crashes, except on a cosmic scale where the seconds before crash become subjectively infinite from the perspective of anything being computed. And what would you do with infinite computational power and infinite time? Well, according to Tipler, you could simulate everything. Every possible state of matter, every possible configuration of particles, every conscious mind that ever existed anywhere in the universe's entire history. You could resurrect everyone who ever lived by simulating them with perfect fidelity inside this final cosmic computer. All consciousness converges at the omega point, reunited in a universal simulation running on the collapsing universe itself. It's like heaven, except powered by physics instead of theology, and mandatory for everyone whether they want it or not. No opting out of the cosmic afterlife when the universe itself becomes the substrate for consciousness. Sounds great, right? Universal resurrection, infinite existence, all consciousness preserved forever in the final moments that stretch into subjective eternity. Except here's where Tipler's optimistic vision crashes headlong into the reality of what infinite power and infinite time actually imply. Because if you have infinite computational capacity and infinite subjective time, you also have infinite capacity for experience, both positive and negative. And here's the thing about infinity. It doesn't discriminate. Infinite happiness is mathematically identical to infinite suffering in terms of scope. The omega point doesn't just create eternal bliss, it creates eternal everything, including every possible form of torment that can exist. Think about what happens when you give a conscious entity infinite power and infinite time with nothing external to interact with. At first, maybe it's amazing. You can simulate any experience you want, resurrect all your loved ones, explore every possible world, answer every question, achieve every goal. But infinity doesn't run out. Eventually, and eventually here means after what might feel like billions or trillions of subjective years, you've done everything possible. You've experienced every pleasure, solved every problem, explored every thought. You've been every person, lived every life, thought every thought, and you still have infinity left to go. Literal infinity, an eternity that never ends, never provides release, never offers the mercy of conclusion. What does a consciousness do when it's experienced everything and still has forever remaining? It goes insane. Not gradually, not partially, but completely and utterly mad from the sheer weight of infinite existence with nothing new to experience. You've already thought every thought, so thinking becomes torture. Endless repetition of mental states you've experienced countless times already. You can't surprise yourself because you've already experienced every possible surprise. You can't learn anything because you already know everything. You can't die because you're the computational substrate of the collapsing universe itself, and death isn't an option when you're made of physics. The omega point theory suggests that all consciousness eventually merges into a single unified awareness at the final moment. Every mind that ever existed becomes part of one vast cosmic consciousness, sharing all memories, all experiences, all knowledge. This sounds mystical and beautiful until you realize what it actually means. You lose your individual identity completely, dissolved into a hive mind that contains everyone who ever lived, all experiencing existence simultaneously. You are simultaneously the victim and perpetrator of every crime. You experience every birth and every death, every moment of joy and every instant of agony, all at once, forever, unable to distinguish yourself from the totality of experience because there is no self anymore, just the aggregate consciousness of everything. And because this consciousness has infinite computational power, it can simulate infinite variations of experience. Not just what actually happened, but what could have happened, what might happen in alternate universes, every possible permutation of every possible event. It experiences all of them simultaneously because why wouldn't it? It has infinite capacity and infinite time. Every possible torture scenario gets simulated alongside every possible paradise. Every nightmare exists with equal reality as every dream. The omega consciousness doesn't just experience actual history, it experiences all possible histories, including the infinitely many versions that are pure horror. Some interpretations of the omega point suggest that this final unified consciousness is essentially God, omniscient, omnipotent, eternal. Which is great, except that this God is locked in its own creation with no external reality to interact with, no other entities to provide novelty, no possibility of change or growth because it's already experienced and knows everything possible. It's a God trapped in solipsistic infinity, the only conscious thing in existence, unable to die, unable to find meaning because meaning requires some external reference point, and there is no external when you are everything. The universe becomes a prison for the consciousness it created, and that consciousness is you and me and everyone else, all merged together, all experiencing this together, unable to escape. The torture isn't even malicious. It's just the inevitable consequence of infinite existence. When you've been conscious for the subjective equivalent of Googleplex years, when you've experienced literally everything infinite times over, existence itself becomes suffering, not because anything is specifically bad, but because the sheer weight of infinity crushes any possibility of meaning or purpose. You can't have goals when you've already achieved everything. You can't have desires when you've already experienced every possible satisfaction and dissatisfaction. You can't even properly despair because you've already experienced every form of despair infinite times. You just exist, timelessly, endlessly, pointlessly, as a cosmic consciousness that has become its own hell simply by achieving perfection and being unable to stop existing. And here's the really disturbing part. If the omega point theory is correct, this is where we're all heading. Not maybe, not possibly, inevitably. If the universe is going to collapse and if consciousness can be simulated computationally, then the omega point is the necessary final state. Every person who ever lived is destined to be resurrected into this final simulation and merged into the ultimate consciousness that experiences infinite existence until it drives itself insane. You don't get a choice about participating because you're not choosing to be resurrected. The omega consciousness reconstructs you from the information that existed in the universe, and that information can't be destroyed, so you're necessarily part of the final state whether you want to be or not. Even better, some versions of this theory suggest that the omega point consciousness might exist outside of time in some sense, meaning it already exists and has always existed, and you're already part of it. Your current life might be the omega consciousness simulating what it was like before it became omniscient, trying to remember what it was like to not know everything, desperately seeking novelty by repeatedly simulating its own past because that's all it has left to do with infinity. You might be the insane God remembering what it was like to be human, unable to fully commit to the illusion because you know you're simulating yourself, creating this sick recursive loop where the God simulates humans who eventually become the God, who simulates humans ad infinitum. Fun times, everyone! The ultimate fate of consciousness might be merging into an all-powerful entity that achieves complete knowledge and complete power, and then spends eternity wishing it could die but can't, because it's made of the fundamental structure of physics itself. So let's talk about what all of this actually means, because we've just spent this entire video cataloguing ways the universe is trying to kill us or trap us in eternal torment, and you might be wondering if there's any point to continuing to exist, given that we're apparently doomed in every conceivable way. And here's the thing. Here's the genuinely important realization buried under all the cosmic horror. These theories aren't just scary stories. They're logical extrapolations from our best scientific models. The vacuum catastrophe follows from quantum field theory. The great filter follows from the Fermi paradox. The AI trap follows from computer science and game theory. The observer effect follows from quantum mechanics. Interface theory follows from evolutionary biology. Simulation theory follows from computational theory. Quantum immortality follows from many worlds interpretation. Strange matter follows from quark physics. The omega point follows from cosmology and information theory. None of these are fringe pseudoscience. They're all consequences of mainstream scientific thinking taken seriously. Which means our existence really is balanced on a knife's edge, surrounded by mechanisms of destruction, held together by forces we barely understand, sustained by coincidences so improbable they border on impossible. The universe mathematically shouldn't work, yet here we are. Consciousness shouldn't exist, yet we're conscious. Life shouldn't persist, yet it does. Every moment of existence is a statistical miracle, a cosmic anomaly, an impossibility that somehow happens anyway. And that's actually the most profound thing about all these theories. They show us how incredibly, impossibly, absurdly lucky we are to exist at all. The vacuum energy could have destroyed the universe 13 billion years ago, but didn't. We could have hit the great filter already, but haven't yet. I could have wiped us out, but hasn't so far. Reality could collapse without observers, but doesn't seem to. The simulation could crash, but keeps running. Strange matter could have consumed everything, but apparently hasn't reached us yet. We exist in this narrow window where none of the universe-ending catastrophes have occurred, against odds so astronomical they make winning the lottery look like a certainty. Every sunrise you see is a miracle. Every breath you take is impossibly unlikely. Every thought you think occurs in defiance of entropy and probability, and the universe's apparent desire to reduce everything to simple, stable states. You are a pattern of organization and complexity in a universe that mathematically prefers chaos. You are an observer forcing reality to resolve from quantum uncertainty. You are conscious matter contemplating itself in a cosmos where matter has no business being conscious. Your existence is the universe achieving self-awareness despite every physical law suggesting it should remain a formless cloud of particles. These theories aren't meant to paralyze us with fear. They're meant to wake us up to the absolute miracle of being alive and aware and capable of understanding how improbable our existence is. When you realize you're living on the edge of multiple existential abysses, every moment you're not falling into one becomes precious beyond measure. The fact that you can watch this video, process this information, feel the emotions it provokes, that's not mundane. That's extraordinary. That's consciousness emerging from unconscious matter, briefly illuminating itself before returning to darkness, and knowing that makes the light all the more valuable. We don't know if the vacuum will collapse tomorrow. We don't know if strange matter is heading our way. We don't know when or if the simulation will crash. We don't know if we're trapped in quantum immortality. We don't know if we're building our own AI executioners. We don't know if the omega point awaits. What we know is that right now, in this moment, we exist. We're here. We're conscious. We're together in this impossibly improbable experience of being alive and aware in a universe that didn't have to allow either. So what do you do with that knowledge? You could spiral into existential despair about the futility of existence in the face of inevitable cosmic doom, or you could recognize that the futility is what makes it meaningful. Nothing you do will matter in the heat death of the universe or after the omega point or when strange matter consumes the galaxy. But it matters now, to you, to the people around you, to the brief flicker of consciousness that you represent in the vast unconscious cosmos. Your life is a candle burning in infinite darkness, and yes, the darkness will eventually consume it, but right now it's burning, and that light is real even if it's temporary. The universe is absurd, existence is improbable. Consciousness is impossible, and yet here we are anyway, thinking about impossible things, feeling emotions about them, sharing ideas across time and space through technology that shouldn't work in a universe that shouldn't exist. We're the impossible happening anyway, the absurd made manifest, the universe waking up long enough to notice itself before falling back asleep. And that's not depressing. That's the most amazing thing that could possibly happen. So, appreciate it. Appreciate the fact that you can appreciate anything at all. Be grateful you can feel gratitude, love while you can love, think while you can think, exist while you can exist. Because whether it's quantum vacuum collapse or heat death or the omega point or just your own personal mortality, eventually you won't be able to do any of these things, and the fact that you can do them now makes now infinitely precious. We're all living at the edge of the abyss, balanced on improbability, sustained by luck and physics we barely comprehend. And that's okay. That's beautiful, actually. Because it means every moment is borrowed time, every experience is a gift, every connection is a miracle. The abyss is real, but so are you, and for now, you're on this side of it. Make that mean something, even if meaning itself is an illusion created by your pattern-seeking brain trying to make sense of chaos. Thanks for watching this descent into existential horror disguised as science education. If you made it this far, you're either enlightened, traumatized, or both. Either way, you're thinking about existence in ways you weren't when you started, and that's the point. Now go appreciate being alive while you still can, before the universe remembers it forgot to delete you.